says D centimeters, so that's centimeters per time is measured in minutes. So on average, it was going 3.125 centimeters per minute. Okay, so you're looking for the rate. How quickly is it happening? Not just what's the change, it's the rate of change. How fast is it happening? Does that make sense? Okay, so when you're doing that, just like if you're doing speed, it's kilometers per hour. How quickly is distance changing with respect to time? Okay, question 5 then, you have that graph. So we talked about this on, I'm just going to kind of draw, something like that, okay? So here, there's where the rate of change or the growth rate is the biggest, because a little change in the x, which is time, so little change in time is causing a big difference in height. Okay, so in this case, we don't have dy dx, we've got dh dt. So the rate of change is what's the difference in h divided by the difference in time. Okay, and they say that between ages 5 and 10 years. So at 5 years, it looks to be about 80 maybe. Okay, does that make sense? And at 10 years, it looks to be about 130. And then we have 5. So you could do this the other way around here. You could do 130 minus 80 over 10 minus 5. Is that okay? And that's 50 over 5. And these are just guesstimates from the graph, okay? Which is approximately 10. And the height is measured in centimeters and the time is measured in years. So you're growing by about 10 centimeters per year on average in those 5 years. Okay, some people might have got 11 or 12, or you might have got 8 or 9, depends on, you know, you're just reading the graph roughly. Okay, so when you're measuring rate, it's what's changing and over what period. Okay. And then question 6, you have a cube of edge length x. Find the surface area. So a cube has basically 6 faces, and each face is going to be a square. And the length and the width and the height are all equal to x. So basically you've got 6, and each of those is an area of x squared. So your total surface area S is equal to 6x squared. Now they want to say the rate at which the surface area changes as x increases. So as your length increases, what's happening to the whole surface area? So what you need to do is S is a function of x. So we can write S of x because it depends on x. That's our function notation. I'm going to call the function S because S for surface area, and it depends on, it's a function of x. So what I want to do is when x is equal to 2, what's S equal to? So I sub in 2 for x, so that's 6 times 2 squared, which is 6 fours is 24. And that's centimeters squared. And when x is equal to 5, what's the surface area? So 6 times 5 squared, which is 150 centimeters squared. Now my change in S is 150 minus 24. But I need to find how quickly did that happen. So while that was going on, so ds is 150 minus 24 over the difference in x, which is 5 minus 2. That is 126 over 3, which is 42. And that is centimeters squared per centimeter. So for every centimeter that the x goes up, on average, the surface area goes up by 42. Okay, so do you have a better feel for that now? You think?
Yeah, that seems easy.
Okay, so it's the rate of change. It's not just the change, it's how quickly that change happens. So you have to decide what's changing and what's causing the change. And what's changing is kind of goes where your y is, but it might be called H or D or S or P or Q or T or whatever. And then what's causing the change is where your x is. Okay, and what we call those in experiments is the independent variable is the x, because generally a lot of the time it's time and you don't really control time, and you want to see how that is causing the dependent variable, which is your y, to change. But don't forget, we can use any letters we want for either of those variables. Okay? So you might have to change your x's and y's. Let me just give me a minute. I just want to see, is it worth trying something? Just give me a sec here. Right, average rate of change here. Sorry, I'm just trying to decide if we want to do more practice. Yeah, let's do a little bit of practice on these. So do you all have your IXL login details? If not, I can give them to you now.
I could see if I can log in.
I can pull them up here on the screen if you don't. So
Right.
I'm going to, okay, so let me assign this to you guys.
Oh, never mind, I'm logged in.
So this is when you go in, you're going to go to 6th year. And I have assigned these rates of change for you. Okay, so BB1 and BB2. And you can start practicing on them just to improve. And we'll just spend like maybe 10, 15 minutes on this. So if you have your username and password, get logged in. If you don't, I'll pull them up here now for you. So who needs one? Okay, who's that? Andre. Okay, so it's first name, last name, 53. Okay. And then your password is Silver87. Can you see it on the screen there? Okay, who else is there?
I think I need mine.
Who's that?
Matthew.
Matthew. Okay, let me just scroll up. Okay, so Matthew Dodd 53, and then 42 Ty TIE. Anyone else?
And then what was the 42 TA?
TIE. I don't make these up.
No, thanks.
Okay, anyone else? Everybody else?
What's it under again?
Sorry?
What's it under?
If you go to 6th year, so when you go in, you'll see topics, scroll down to 6th year, and then
Yeah, I mean,
you'll see it highlighted BB1, BB2.
oh, okay.
So it's just to get you a bit of practice in this.
Introduction to derivatives, is that it?
That's it, yeah. And it should be rate of change then as the specific one. Have you logged in, Tyke?
Yeah.
Anyone else need login details? are we getting on? I think there's a bit of delay here. I'm only seeing one logged on. Is everybody on okay and working?
Yeah, miss.
Yeah.
For the average rate of change,
Yeah.
I missed the start. Like, what do you
So
multiply
you
or
can see what's
calculate?
changing. So what's changed and how fast it's done. So what's your
It's
question tag? Yeah.
find the average rate of change of k in brackets x equals minus 2x squared over intervals 5 and 6.
Okay. So what you have to do is, what you want to do is find k of 5 and k of 6. Okay, because you're subbing in 5 for x and then you're subbing in 6 for x. So that's your two k values. So between
Okay.
6, x just has a difference of 1, and it's basically what's happened to k while that's going on. So
Oh, okay.
So you sub in 5 and then you sub in 6, subtract them. So it's k, if you
Oh,
like, k5,
so
k6 minus
k5.
k5.
So k5 would be like minus 10x squared.
No, it'd be because you put in 5 for x. So 5 squared is 25 times minus 2 is minus 50. And then you put in 6 for x. So let me just, can you see my screen here?
Yeah.
See, I'm up in the top here. So k of 5, wherever there's an x, the x is changed to 5. So wherever there's an x here, so the 2 is still minus 2, but the x is changed to 5.
Okay.
It says do the squaring first, that's 25 times
Yeah.
2 is minus 50. And then you do k of 6. So wherever there's an x, you change it to 6. So that's 36 minus 2 is minus 72. So
Yeah.
to 5, you've got minus 72, minus 50 is plus 50. And then while that was going on for k, x was changing from 6 to 5. So that's the difference in k divided by the difference in x. So that's
Okay.
minus 22. No, it's not minus 22. No, you're wrong there. Yeah, okay, minus 22.
Okay. Thanks.
That makes sense? So you sub in your different, one variable is going to make the other one change. So see how it changes and then divide by the change in the first variable.
Yeah.
All doing okay?
This doesn't matter if it's a negative or positive.
Yeah, because so you need to put in the negative. Basically, if as the first one is going up, if the second one is coming down, then your rate of change is going to be negative.
Yeah, okay.
So if one goes down as the other goes up, then that has to be negative. So you need to get, just like with slope, you need to make sure you keep the x's and y's in the same order.
Okay.
So it doesn't matter which, like if you put x1, y1 first or x2, y2, as long as you keep them in the same order.
Yeah, grand.
So once you've answered a question, I'll be able to see it. So if you want to ask for something to be explained, let me know. So Jamie, are you able to get, are you on? Gordian, are you on? I think it's on. Gordian. So Jamie Herbert, you able to get on?
I'm on.
Yeah, sorry, I can see accordion. It was just my screen wasn't big enough. Yeah.
Right.
So I think what I'll do for homework, guys, is just practice on those, and you can see you kind of get a smart score. So if you can all get to a smart score of at least 70. And the thing with this is the more you do correct, the quicker you'll get to your smart score and the less questions you'll have to do. If you keep getting them wrong, you're going to have more and more questions to do. So think about it and get them right.
Do we just need to do BB1?
Yeah, don't put BB2, just BB1 and get it to at least 70, preferably 100, but at least 70.
Is that just our homework then?
Yeah, so that's all the homework I'm giving you is just keep practicing on this.
Okay, grand, thanks.
So anyone, any questions? Are you starting to get the hang of it? Andre, do you want a hand? Or are you starting to figure it out? Okay, good. Just take your time, get it right, because otherwise you're going to have more to do. So it's on the computer, but you're probably going to need a piece of paper to scribble things down and work them out. Yeah. Other Andre, how about you?
Yeah, I'm all right.
Starting to get the hang of it.
Yeah.
Okay.
If it says like x equals 10 and x equals 14, are they just the intervals? That it's just written a different way, like?
Yeah, so your dx then would be 4 because 14 minus 10 is 4. So it's
Okay.
what was y when x is 14 and what was y when x is 10. And then so it's the change in y divided by the change in x.
Well, is there meant to be a y in the question?
It doesn't have to be y, it might be something else. What does your question say?
Find the slope of a secant line for f of x is equal to minus 3 square root of x between x equals 10 and x equals 14.
Okay, so we're gonna do, that's a tricky one. 'Cause it's,
Like, would I just sub in 10 for
yeah, 10 and 14 for x,
in the minus 3 thing and then put it over?
and put it over 4, yeah. But it's weird to give you square roots of things that don't actually work out. Yeah, let me know if that one doesn't work, and I can come up. It doesn't come up. I can only see the ones that you've finished.
Yeah.
So it'll come up on my screen after you've done it. So it's a problem.
We got the answer right.
Well done. Did it want it in decimal places or?
I don't know. I just put the thing over 4, and then because I can't type in thirds, I just changed it into a fraction, and I got like 0.434, but it only wants it to a tenth, so I put in 0.4.
Good. Well done. That was a tricky one. Gordian, how about you? You need a hand at all?
Yeah, I mean, like, I was kind of stuck on the first two because I didn't know what to do. But then on the third one, I got it wrong because it was a minus.
No, it's just a sign. Yeah, you have to be careful. It's like when you're working out slope, you have to do y2 minus y1 over x2 minus x1. And if you swap them around between the top and the bottom, it's going to change the sign. Yeah, I think that's happened to a few people. But, I mean, I think this is good practice. Would you agree?
Yeah, it's very helpful.
Yeah, good. Okay, I'll leave you to it. Send me a message if you have any problems. And the thing is, it goes through the steps of how to answer the question if you do get it wrong anyway. So if you're stuck, look at those and figure out why you're not getting it. But I think after a few of them, you should start to